Hello, everybody, and welcome to the Microsoft Data and AI user group. My name is Adriano da Silva, and I'm your host. And thank you very much for making time in your busy schedule to join us here tonight. And hello, everybody, and welcome to the Microsoft Data and AI. Please do remember to subscribe, click the bell, and like the video. And tonight we have, as always, a very special guest that is joining us here at the Microsoft Data and AI user group in our World Series. And today we have James Serra. Hi, James. How are you doing today?
I'm awesome.
All right, and welcome to the Microsoft Data and AI user group. It's your first time here. I hope that it may be the first of many in the
Yeah,
future.
I'll go for that.
All right. And where are you located at?
I am in New Jersey, just right outside of the city.
All right, folks. So today we are in the US, from New Jersey to the world here, James Serra, and he will be presenting on Azure Synapse Analytics Overview, a data lakehouse. Can you give us just a real quick, just what it is about data lakehouse? I know it's a paradigm. Can you elaborate just a little bit? And I know you cover in more detail during your presentation.
Yeah, sure. Azure Synapse Analytics is a new part of it is a new product in public preview, and one of the features about it is where it combines a data lake and a data warehouse to be what's called a data lakehouse. And at a high level, the idea is to pull in data, whether it's in a data lake or in a relational database, to do it very easily with T-SQL and with on-demand compute.
Awesome. So that sounds very interesting and exciting here. And tell us about how you feel about this new advance. Do you see that? I see that a lot of interest Azure Synapse, and that is one of the directions we will be seeing Synapse going towards to.
Yeah, there's a lot of customer interest in that, and almost on a daily basis, I'm talking to customers and demoing this product, and it's really been heavily invested in Microsoft with the resources they put into this product and the amount of features that they have that are out now and that are planning to have. So this is really the star product that Microsoft has when it comes to data warehousing. And so I'm showing you part of that tonight, and you can expect a lot more over the next coming months.
Yes, indeed. I've seen a lot of different news coming about it, and a lot of how can I say new features coming in on a quite regular basis, on a monthly basis or weekly basis at a time. So definitely see the investment and the push forward, the building momentum, and the interest from the customer side as well.
Yeah, it's it's extremely popular. I think it'll continue to get popular and be one of the most talked about products at Microsoft, especially based on what I've seen in the last few months.
Yes, very exciting, and I see it's a very powerful technology as well. So with that, I'm going to transition to you and let you, carry out the presentation here for us. Thank you.
All right, I am going to share my screen. Is it coming across okay?
Yes.
Great. Well, welcome everybody. This is a presentation called Azure Synapse Analytics, a data lakehouse. I'm actually presenting this at the PASS Virtual Summit coming up. So this is why it's on this slide. So you could think of it as you're getting a free access to this presentation that'll be similar to what I will do for the summit, which is next month in there. I'm currently a data and AI architect at Microsoft. I spend most of my days in customer engagements talking about the modern data warehouse, which Azure Synapse Analytics fits in very well. And most of my engagements with customers are half day or sometimes full day design sessions where we whiteboard out what the solution would look like if they want to build something in Azure in the cloud and collect all this data and make better business decisions with it. And you'll see Synapse Analytics is a great tool for that. I have my email here, so feel free to email me afterwards if you have any questions. I'll pause along the way to take some. And my blog is jamesserra.com, and I have a lot of blogs on Synapse Analytics, especially recently on there. So some of the topics I talk about, I may dive a little bit deeper into my blog, so if you want to get more information that way. Going through my long career of 35 years, the short of it is I was a DBA for many years, always focused on Microsoft products. I joined Microsoft 6 years ago, and this is my third role. The one I'm at now as a data and AI architect at the Microsoft Technology Center, or MPC, in New York City, is where we used to have all these in-person engagements. Of course, now with things changed since March, we've gone all virtual and will for the foreseeable future. And it's a very interesting role because I get to see a lot of different companies of different industries, but a lot of the patterns are the same. And this is where I see that this product's really going to help customers in that migration to the cloud. So what I'll talk about today is I'll introduce Synapse. I will talk about MPP, the massive parallel processing concept that is behind Synapse. It's important to understand that. And then I will do a demo, and I'll spend a good deal of time going through a lot of the major features in this product. And then I'll end it with some more details on the particular storage and performance optimizations that are inside of Synapse. Here's what we think about a high level of Synapse. This data lake concept, which has been around for a bit of time, is the idea I can take data and I can land it in a data lake, and I can do experimentation on that data. It's easy to explore the data once it lands in there. It could be data that's non-relational, semi-structured, non-structured in there. So that concept has been around a while, and it's even longer has been data warehouse. This is the relational data. So this is where something that we've seen relational models being built for many years, and this is where you get great performance and excellent security on there, and this is excellent for operational type data. So what's happened over the years is a lot of companies have ingested data in a data lake, the big data, which I define big data as data knowing the size or the type or the speed of the data, and they'd have that separated out from relational data. And that has some issues because many times you'd have different technologies that were used depending on if the data was in a data lake or in relational data. And so what Synapse is doing is combining those two worlds together to have a data lakehouse. And this is what you'll see is we have one single pane of glass where you can access data using regular T-SQL, no matter if it sits in a data lake or a data warehouse. You can either provision a compute to go against that data, or you can use on-demand compute. So there's one big advantage is that we have that is different from previous solutions. You'll see there's other features I'll cover that are new to this product too. If we look at the modern data warehouse, traditionally it's looked like this. We have all the source data, we ingest it using Data Factory, then we clean it, prepare it using Data Factory or Databricks, then we transform it and maybe model it into a different format using Data Factory, Databricks, and then we land it into SQL Data Warehouse on there. And then we have Power BI that's on top of that, and the data that's landed in the data lake is using data lake storage. Well, it's a lot of moving parts in this, a lot of different products, and it was confusing to end users when they're trying to build out a solution. So where Synapse comes in is it tries to overlay all of these products under one umbrella, one roof, and makes it very easy then to build out a modern data warehouse solution. And it'll really come across when we go through the demo. There has been confusion with customers when we talk about what products are available now and what I'm going to demo that's in public preview. If we look at what's under GA, and we've had what was previously called Azure SQL Data Warehouse. We simply renamed that and called it Synapse Analytics. And that product has a bunch of features. New features came in, new features are in public or private preview that are being added to this. And if you go to the Azure portal and you type in Synapse, you will see this one option called the formerly SQL Data Warehouse. Now, what we came out with, it must be over a year now, was this public preview version. And if you do a search, you'll see this workspaces preview, and that's the keyword, the workspaces, because that unlocks this public preview version, which gives you all these additional features. Now, these features are still imported or included in the public preview version under what's now called the SQL pool. So that's the same concept as well within the SQL Data Warehouse. It's a relational compute and storage, but there's a bunch of other features that are on top of this, included in this public preview, which is the focus today. I created this slide to show you at a high level what is included in this public preview of Synapse. We have the concept of workspaces. Under each workspace are going to be all these features that I'm going to talk about. The new feature is Azure Synapse Studio. So everything that you'll see in the demo is done underneath this one single pane of glass. What it can do under that single pane of glass is you can ingest data through pipelines or data flows. These are the same concepts, or it's actually the same code that's in Azure Data Factory. We just don't call it Data Factory inside of Synapse, and I'll demo those. So you can ingest data and land it in a number of different storage areas. One is your traditional relational database. That's the SQL pools, or called provision pools, that was in the what's in the GA version of SQL Data Warehouse. That uses a traditional T-SQL on that. Also on a single place of glass is the ability to have Data Lake Store Gen 2. And you'll create this outside of the workspace, but you'll link to it inside the workspace, which I'll demo. Now that data lake, it's integrated and inside Synapse Studio, and then there's this new option called SQL On-Demand Pools that allows you to use regular T-SQL against this data that's sitting in the data lake. That means I can go and use Power BI, and it could fire up an on-demand pool and go into the data lake and query that data. So you're not having to move it to a relational database. You're not having to pre-provision anything. It's on demand. So it's quick solution with limited cost. And you're using T-SQL, which has never been possible before against the data lake. And you'll see that'll become clear in the demo. Also, what is new is Spark tables. So for those of you that were using something like Databricks and Spark notebooks, it's the same concept, but it's using Apache Spark. And there's Apache Spark pools that you can fire up within the environment. And then I can use that notebook to pull data from Spark tables. I can also use on-demand pools to pull data from the Spark tables that were created using regular T-SQL. And then finally, we have Cosmos DB, which through a new feature allows you to use regular T-SQL on the Synapse Link feature to pull data into the on-demand pools with regular T-SQL. So in the end, I'm able to access all this data with regular T-SQL through the on-demand pools. Extremely powerful feature. And also having Spark in there means that you can pretty much do anything you need to within the Synapse Studio. If we look at now what the new modern data warehouse looks like, it's this. I have all this data that I can pull in and ingest it using the Synapse pipelines, which is Azure Data Factory. But now when I want to explore it, see what's inside of these files that are sitting in the data lake, I can use Synapse Studio. I can pull that into a pipeline, or I can use Synapse Spark. When I'm trying to transform it and clean it, I have all these different options now. When I want to model it, I still have the ability to move it into a relational database. And then I can use Power BI on top of that data. I can use Power BI if it's sitting here too. because the data is going to be sitting under Data Lake Store Gen 2, which Power BI can access. So this is what really the new modern data warehouse looks like, and it opens up a lot of possibilities, and it allows for a lot of cost savings, and you'll see that going as I go forward in the demo. So the big thing is Synapse SQL Serverless. This is a great new feature, and the idea is this service allows me to put a T-SQL front end over data sitting in a data lake. So with that T-SQL feature, I can not only use products like Power BI, but Data Studio, SSMS, any third party that uses T-SQL will be able to use the Synapse on-demand query service to pull data from inside a Data Lake Store Gen 2 on that. So with the serverless, there's no infrastructure, it auto scales, and you'll see you can define it to scale up and down, and it only pays per query on there, so it could be tremendous cost savings because of that. And that gets into various ways to save costs, but with customers, you have to think through what is your use case, and is this the best way to go? Is it also part of my use case where I should have provision? In many cases, customers are using both. So I'll talk through some of that as we get through the demo too. So this is a way to think of how I can now use serverless. I have basic data exploration, which I can come in here and query files sitting inside of the data lake to see what features they have, data is inside of them. I also have the logical data warehouse concept. So you think of federated queries is another name of it. It means I can look at data that's sitting in, I had a little trouble with I can look at data I can link data as it is inside of other source systems, whether it be a relational database or a data lake or Spark or Cosmos DB. And the last part of the demo will show this. And then data transformation means I can use SQL Serverless and T-SQL to clean data. So if I don't want to use Data Factory, if I don't want to use a Spark, if I've created a lot of stored procedures that are using T-SQL, I want to continue using them, and I want to save money, I can just run that SQL on top of the data sitting in a data lake, clean it, and write it back out to the data lake. And all that is done without having to pre-provision anything, and done using the T-SQL, which we all know and love. A little bit of introduction of MPP Technology, massive parallel processing. Sure.
Hi, James. We have a question here coming from Rose. She has a couple questions. One is, what is the difference between Azure Synapse and Azure Data Factory?
Azure Synapse is the product that is for a modern data warehouse. Now, inside of that, think of it as an umbrella name, that Synapse has all these products underneath it. One of those products is Azure Data Factory, which is an ETL tool. If you're familiar with SSIS or Informatica, that's what Azure Data Factory is. It's to move data from point A to point B, and also to be able to clean data with that product in there. So if you think of Synapse as containing many products underneath it, as you'll see in the demo, and think of Data Factory as one of those products.
All right. And another question is, does this mean that we don't need Azure Analysis Services to consume information from Power BI? I think she means like Analysis Services would work as a data source to Power BI. We will only use Synapse with SQL or T-SQL in the case?
Yeah, and this is a blog that I went into great detail on, because Azure Synapse Analytics, this is where you can store data in aggregated fashion. You create these cubes or tabular models in there. And traditionally, you've done that because if I'm querying data against a really large database, a really big table in there, it may be too slow, especially if I'm using dashboards where I need millisecond response time. So Analysis Services created that aggregation cubes. With Power BI now, it is a superset of Azure Analysis Services. So I see customers now not using the Azure Analysis Services anymore because Power BI can do almost everything that Azure Analysis Services can do and then some. Now, if you look at Azure using Power BI, when you have this really large database, which could be billions of rows, there's various ways to pull that data into Power BI and aggregate it. Or you can use features like direct query to query that data as it sits in Synapse and not have to pull it into Power BI. There are, and I'll talk about this later, there are methods to speed up those queries with this large amount of database rows in there. And that's using some of the features with Synapse called materialized views and results set caching that will make it so you don't even need to create a large tabular model in that. So there's a lot of complexity when it comes to options in there that I've dribbled on about, is that in many cases, customers are no longer using Azure Analysis Services.
All right, great, thank you.
All right, thanks. I'll pause again in a bit to answer more questions that come up. So when we look at Azure Synapse Analytics, and it's an MPP technology, this difference between traditional SQL Server called SMP, symmetric multiprocessing, where you have the ability to scale up, but at some point you hit a limit. And when you have queries against that, they're all sharing the same memory disk, especially on-prem. You talk about network controllers and SANs and such. So they have issues where a query can overwhelm and take up all the resources. And at some point, you run out of space or resources, and you have to purchase another server, and you have to back up and restore everything. And it's a long, drawn-out process. And at some point, you may reach a limit, and you can't go any higher. And this is where MPP technology came in. It's multiple parallel processing. You can scale out, and you can dedicate resources to individual queries. If you're familiar with products like Nespeza or Teradata, it's the same idea, that multiple parallel processing underneath the covers to get the ability to query data that could be billions of rows and do it just in a couple seconds, which will be part of the demo. If we look at how this works behind the scenes, you'll have this control node. That's the face of Synapse, and everybody's going to interface with this control node. But there are compute nodes behind the scene, and there are various storage mechanisms behind the scene where those can be scaled out. So I can add more compute nodes on here and have more storage where the data is all split out to allow for tremendously fast queries. So the way this works is through the data movement services. And it's an additional feature on top of what you think of a query plan. And if I look at how this works, if I have an end user and they will connect to the control node, they will submit a query. Now to them, they don't realize anything that's going on behind the scenes. It all looks like it's happening without this complexity. And the way that happens is the control node will create a query plan, but it's different than your traditional query plan, and that as it parallelizes the queries. And it distributes those queries under various compute nodes. Each of those compute nodes working against the storage. That's where that DMS comes into play. So it runs that query locally, filters the data, and then sends it back, mashes it up in the control node, and it sends it out to the end user. So this is where it's all parallelized. And an analogy would be if I had a deck of 52 cards and I was asked to find the king of diamonds, I can go and flip through it. It may take me some time. I can scale myself up. I can make myself faster. And maybe I find that king of diamonds faster, but there's only so much I can do. If instead I take that deck of cards of 52 and I split it into 26 people, each of get 2 cards, and I ask them to go find the king of diamonds, it's going to happen a lot quicker. So that's what you think when you scale up. The compute is what you're getting on there. Now, this is where the difference between SSMP is that think of the way you lay out the data as the big difference between SMP. Traditionally, with a data warehouse, you have fact tables and dimension tables. And what you do for those dimension tables, which are usually smaller, is you replicate the data to all the various storage. So it's duplication of the data, but data is very cheap, and this is going to be worth it for the processing speed that you're going to get from the queries. So those small tables get copied. The fact table gets chunked up and split out among all these various storage. We'll see there's 60 of them with Synapse. And you'll do it based on a hash key or round robin. And what happens then is when you query the data, usually you almost always combine a fact table with dimension tables. So because the dimension tables are copied into the compute nodes, when it's combined with the fact table, I can get my answer inside of that compute node without moving the data all around. Because if I didn't do it this way, I'd have to find a dimension and say, oh, it's over in this storage. Let me move it into this compute node and use the combine with the fact table in there. The copies allow you to do everything locally and pass back the results without shuffling the data. How is that different than regular SQL? Is the create table has this distribution statement in there. And you specify how you want to distribute the data. If you use a hash key, something unique, so you get even skew among all those distributions. And when you create this statement and execute it, what it does is sends it to the control node, and then the control node keeps the metadata on there, and then it sends a create table to all the individual compute nodes, and each of those compute nodes then runs a create table and lands the data and splits it up in there. And within each of those compute nodes, you can continue to use other features like partition to get even faster speeds. I find most times customers don't need to bother with this, but if you need to squeeze out a little bit more performance, you can still partition. Now, the performance is based on what's called data warehouse units, or DWU. The higher you slide this scale up, the more CPU, RAM, and I/O you'll get. You'll cost more, but you'll have the performance you need. And if you do not, you can just scale this up, and it's pretty linear. So if I go to a DW unit of 100 and I go to 200, I'll pretty much double the speed of my queries on there. So you can go up and down. You can manually change this. You can also auto pause. So if you're not going to use it over a certain time, say on the weekends, you can save costs by auto pausing it. And eventually we'll have a feature that'll auto scale and auto pause, but for now it's a manual operation, or you got to write some, say, PowerShell script to run at certain hours of the day. The architecture when the storage comes behind is there's 60 pieces of storage. Think of them almost as 60 hard drives out there. And if I have at DW100, I'm going to have one VM fired up that's going to have the compute against all 60. As I scale that up, I get more and more virtual machines that are fired up for compute that are going into storage. So if I went up to 600, I will get 6 compute workers, which are VMs, that'll work against those 60. So 1 per 10. If I go all the way up to 30,000, you're going to get 60 of those virtual machines going against the 60 storage. So it'd be a one-to-one relationship on that. So that's how you get massive amounts of performance. So I'll pause there as I get ready to jump into the demo for any questions.
Yes, we do have a question. Enrique would like to know, can we do that same partition process using Azure Data Factory?
If you are using Azure Data Factory, you can have a task in there that would create the tables or scale up and down, if that's what you're getting at. You can think of Data Factory as an orchestration tool that could either move data from point A to point B and clean the data. It can also interface with Synapse to scale it up and down, to pause it, or to load data inside of Synapse. So that's frequently used. Data Factory is frequently used with Synapse. You'll see how it's integrated when I go through the demo.
All right, thank you.
All right, so let me jump to the demo. So you'll see here, I'm in the Azure portal, and I can go into the Synapse Analytics, you'll see here, and create a number of workspaces. So to do that, I just click the Add button. And think of workspaces as really just a bucket where you're going to pull your resources in there. So I specify where in Azure I want to have it, which region, under what resources I want to call it, another way to put it under a bucket. And once I do that, I will get this workspace after just 2 or 3 minutes. Inside this workspace, you'll see on the Overview tab the SQL endpoints. So over here, these are important to keep in mind because I have the option of going into Synapse Studio, which you see right here, that single pane of glass. But if I prefer to use tools outside of Synapse Studio, like SSMS, I can just enter this SQL endpoint, whether I'm using the provision endpoint, which is SQL Data Warehouse, or the new on-demand on that. So don't have to use Synapse Studio. When I go and fire up a workspace, the first thing I'm usually going to do is create some SQL pools and Apache Spark pools. So SQL pools are the SQL Data Warehouse, the provisioned compute, the DWUs I just showed you, and along with the compute is a database that's created for that. So it's a one-on-one matchup on there. So if I come in here, you'll see I have the ability to choose the performance level and the cost that's going to be for each of those. And then once I hit save for this, I will have this SQL pool fired up. I can create multiple SQL pools, each with its own database. And then you'll notice here I have the on-demand, which is there by default. And we'll see that used in the demo. And for the SQL pools on here, you can see I have the options to resume it or pause it, resume it, scale it up and down, and such. Now, for Apache Spark pools, the same thing. And if you're familiar with Databricks, this will look similar. It's the same process. Is when I go under new here, I can specify the node size I want for this Spark compute. I can auto scale it if I wish and choose it the min and max of the auto scale. So as a query gets submitted and it needs more resources or many queries are submitted, it will fire up more nodes based on what I indicated here on demand and then shut them down when it's not needed. Also under additional settings you see is the auto pause. So I can say in this case, after 15 minutes, I want it to shut down. So it's in between the provisioned and a paper query. It's sort of like a paper cluster in a way. And so customers who are familiar with Databricks get it right out of the box how this works. And for those not, it's pretty straightforward in setting this up and saving a lot of costs by having this number of minutes, with the trade-off that if something gets shut down because it paused, there's a startup time of 4 to 5 minutes. So you have to see where and balance that out where the end users are going to be happy or not with that. And this is where you can have different pools. So I can have a pool that's maybe has a small amount of node size and nodes and run it continuously for those small queries. And then maybe have a very powerful Spark setting on here, large node size, auto scale, but a small auto pause option in there. So it's not run all the time and being charged a lot on there. And then I can create as many pools as I want, and I can assign users to each of those pools. So it's a way to track costs, save costs, or divide out work tasks. Maybe I'll have data loading jobs that are going to go into the higher compute, and dashboard queries type of queries go against the smaller compute. Okay, so once I set all that up, I can then go into this portal or this workspace on here. So in my case, I'm going to go open it up with Synapse Studio, and what you'll see is you'll come to this home page here. And the one thing you'll notice is this ingest. So if I click on this, this is familiar to those of you who've used Data Factory before, in that it's a wizard to copy data from point A to point B. And it's very straightforward. I can come into connection. I can choose an existing connection I created before or a new connection. I can come in here and say, I want to pull data from, say, a Data Lake Store Gen 2, or maybe I want to pull it from SQL Server or Amazon Redshift. And I put the connection information in there, and then I specify what I may want to limit the data to pull in. So if I look at, say, this data lake on here, I can specify the file or folder that I want to only concentrate on. And then I go to the same thing with the destination on here. And it's the same thing. I put the connection information. I tell it where I want it to go to. And that's it. When I click create, what happens is it creates a pipeline. I can run that once. I can run that on the schedule. And that will fall, that whatever I create, if I go to integrate tab, will fall under pipelines. As an example, I can look at this SAP HANA, and that copy tool wizard will come up with a copy data. So if I look at this, you'll see under source and sync, or everything I went through the wizard and set up. And then I have the option of, in this case, it copies data from SAP HANA into a data lake, and then I can go and take that data in the data lake and use this other feature within Data Factory called the mapping data flow. And I can take that data and I can start doing things with it. I can clean it, aggregate it, reduce the columns, combine the columns, and eventually put it into the data lake under a clean layer, or I can put it right into Synapse on that. This is a very feature-rich option. It's all visual, so I can just come in here and say I want to query and aggregate just the last 5 years of data. There's a visual expression builder that makes it very easy to filter out this data on here. So it's all these functions, and it's uses IntelliSense, and I can just go in there and put in what I want to use. So I would say it's not no code, but a low code. Basically, you're just filling in properties on here. And I can even click on this drop down. I can add other things in here. Say I wanted to join data together between two tables. I go in here and it's got this nice pretty diagram of what kind of join I want to do. And so it just made your life so much easier by using this tool to move data and clean the data along the way. Now, the next thing you want to do inside of Synapse Studio, and notice as I'm going along here, I'm never having to leave Synapse Studio. I'm never leaving this tab, which is a big difference than the way things were done before. If I wanted to go to a storage account, I'd have to go back to the Azure portal. Instead, what I can do, if I go under Manage, under this Link Services, right here, I can click New, and I can link to all these different sources, and then they will become incorporated within Synapse Studio. Now, right now, it's limited to Data Lake Store, Blob Storage, Power BI. Eventually, there'll be other products. But for right now, those are available. And once I set that up, then I can start using those within other hubs, one being the Data Hub. And what I'll show you now is different ways to query the data. And I have this chart that I made here to show you the different ways we're going to go through this. So if we think about some of the compute options I showed, we have this provision pool, we have on-demand pool, and Apache Spark. Those are the compute options. And then we have 4 different types of database storage that we can put that in there. Relational database, Gen 2, your data lake, Spark Table, or Cosmos DB. And then within each of these, you're able to right-click all these objects. And I put here the different ways, different things you can do when you right-click it, as you'll see as I go through. But the first one is using the on-demand pool to query data in the data lake. And this data I'm going to show you is using Parquet. So this is where it's almost magical how awesome this works. If I go to data and linked. This is the data lake store that I previously went and linked on the manage. And this is the storage that I linked to with it has all these containers. One of these containers is the Twitter data. Underneath this Twitter data, you see these Parquet files. Now, previously, if I wanted to look at this Parquet file, I'd have to go fire up a Databricks cluster, attach that storage to the Databricks cluster. I'd have to fire up a notebook, a Spark notebook, and then using that attached storage, I'd have to write some Spark SQL to query this data. That was a long process. A lot of mistakes can happen. It was costly because you're firing up a cluster now, and it could take a while before you figured out how to see the data that's inside this Parquet. Now what I can do is I can, inside Synapse Studio, I can right-click this. You'll see this option here where it says select top 100 rows. If I click on that and I click run, you will see this open row set. This is the magic that allows me to go and it automatically specified where this data was being stored in the data lake. And voila, at the bottom here is the results of that, which took 4 seconds. I can see that data at an instant. I can click chart and I can start playing with that data. So this is a great way to explore. I chose just one file here, but I could just as easily go and put a wildcard character in there and say, just show me all the Parquet files in there. And within a couple seconds now, all those Parquet files are shown on there. This is using SQL on demand. You can see up here. And that's it. I can even go and say, well, I can use T-SQL. So that means I can use where clause. You bet. I can say where city equals in the closet. That's a weird thing that popped up, but let's try that. And it'll filter out that. So regular T-SQL, I'm paying per query. How much easier can this be? It really can't. This was amazing when I first saw it now, and customers really love this on there. I can also, under this use database, you see I can choose this test SQL on demand. So the on-demand database in Synapse is just metadata. There's no data associated with it. So I can store metadata on there. So if I choose on demand on here, I could take this statement and make it a view and just say create view as and call it, say, Twitter view. And then I run this, and what it's going to do is, if I remember my syntax, is store this view under this test SQL on demand. So it's the on-demand database that's all metadata. So now if I go to data and workspace and I pull up that test SQL on demand, and let me just refresh it. Oh, it's already there. You'll see that I have the Twitter view. And if I do a script, if I do the select top 100, now I'm getting the results there. So now think of this as you're putting almost a metadata on top of data sitting in a data lake. So it could appear to the end user that this is actually in a relational database when it's really sitting in a data lake. So that's what's amazing about this, is you now have the ability to say, maybe I don't need a relational database and I can save a lot of money by just creating views on top of the data sitting in a data lake. There's a lot more to that, and there's a lot of trade-offs and to do. And when you get into, do I need a relational database? That could be a whole separate conversation to say in yourself. But you can see now how great this could be. Maybe I just want to explore data, and I want to move it into a data warehouse, relational data warehouse, and I just quickly create a view, and I can go tell an end user, just go execute this view and play with the data and see if it's valuable, run a one-time report and such. Another thing I can do, if I go back to my chart here, is I can use Apache Sparkful against data that's sitting in the CSV. So going to back to the storage account here, I see this customer CSV. So I could also, this supports Parquet, CSV, and JSON. In this case, I'm using CSV. Another option that I have under CSV, which is not for Parquet yet, but will be soon, is a preview option. So I can right click it and just go preview. And just like that, I can see what's inside this CSV file. Now I could say, oh, this is great. I'm a data scientist. I want to use this data in a notebook, a Spark notebook. How can I do that? Well, I right click it and I click the new notebook and I go load to data frame. And I choose the pool I want to use it on when I click run. So this has created the code for me to load that data in that file into a data frame in Spark. And from here, I can start building out my notebook and using that data that's in memory. So it's a quick jump start to building a notebook in here. And you'll see with Spark, I have the ability, this Open Spark notebook, which they just today added a new feature to enhance this notebook. And if I go down, let me show you the, can't quite see it. This Azure preview was just added today, and it gives you more features in the notebook. So I also then choose, so while it's got these 4 languages, I can switch in and out of the notebook to use that. And then I choose which Spark pool to attach it to. And you saw before I had created a handful of them. And then that's it. Now this will take 4 or 5 minutes to run on the first time. And then it'll time out after a couple of minutes if nobody uses it again to save money. But it's an awesome feature to get a quick start and create these notebooks. Now you may say, well, I want to do, how advanced can these notebooks be? Well, it's all open source Spark. So any libraries that you have can be incorporated into these notebooks on here, so you can build it out. Another feature that you can do here is if I can take this provision pool that is, so that SQL pool, that is what was used to be called SQL Data Warehouse, is an option where I can query data in that. So if I go to the workspace and I go to databases, and that SQL pool I created, I called it the SQL pool database too, SQL pool 1 database. And then if I go and right click a really large table called sales, and I can just right click that, this works like SSMS does. And right away I can, within a few seconds, have a query output that shows the relational data sitting in there. Now, moving on to another one is I can now say, well, what about Apache Spark pool against a relational database? So I pull this into a relational database, but maybe I want to use this in a notebook. Well, what I can do is if I go to another table here, say country, and I right click it, you'll see I have this option called new notebook, load a data frame. So I choose the pool again and I run it. And this is going to take that data that's in the relational database and put it in a data frame. And then I can go and use that in a notebook now. So you can see how easy it is to use various different technologies once you're inside of Synapse Studio. We still have an option for using external tables. So I can use a provision pool against an external table. So this was available in SQL Data Warehouse. So this is a way that I can have a compute of a SQL pool go against data sitting in a data lake. Now, and it uses the Polybase technology. Now this will be enhanced in the near future, in early next year, hopefully to use even improved technology than Polybase, but and make it easier than using the external table concept. But for now, I can continue using that. So to show you how that works, if I go back to the link, then I go back to Twitter data, and I right-click that Parquet file, I have this option under here, create external table. And where do I want to create that external table? Well, I can create it under the SQL on-demand pool, or I can create it under the SQL relational database pool on there. And then I can call it, say, external Twitter, and this create statement will then go and show me all the SQL it's going to use for that, and I can run that, and then what I'll have is an external table that points to this data set in a data lake. So Then we made it easier by doing all these commands for you. And then I can then go under the SQL pool where I created this and run a query that's going to pull data from this Twitter file. So to show that, if I go back to the workspace, I go to SQL pool, I go to external tables, refresh that, you'll see I now have this Twitter, and I can do a script and just run it, and boom, I now have the compute performance that is this compute for under SQL pool that is using to query that. It gives me options. Now most cases you're going to use the on-demand compute to query this, but you can do it this way, and then I can then combine this data with data in the relational database for a query. All right, a couple more options I'll show you for this. I can also go into an on-demand pool and use the Parquet format. So if I go to a notebook under the Develop tab, you'll see I have these various notebooks that I previously saved on here. And one of them is, oh, I'm sorry, let me go to the table that I wanted to show you. If I go to the Spark, yeah, go ahead. Yeah. So if I go to the Spark table example in this notebook, this shows you how I created a database that's a Spark database and a table underneath that Spark database. And I inserted some values into it, and then I selected from it. So here's a really cool feature is the idea is I can go and maybe I like Spark and I create a notebook and I do things with it, including creating a table and I insert a bunch of data to it. Then I decide I want to query that data, but I want to do it outside of the Spark notebook. And what happens is whenever I create this database and this table, the metadata of that is copied over into the SQL on-demand metadata database, and allows me to query that Spark table, even though the Spark table cluster is not running. So after I did this, you think, oh, I can only use this in Spark. No, if I created this database on the New York Taxi and created this test table, if I go back to the workspace and I pull up the New York Taxi, this is the Spark table, you'll see I have this test table here. And I can then right-click this, do new SQL script, select top 100, run it, and you'll see here I'm using this SQL on demand against this database. This was copied from the Spark information, and I can now run a query against that. So I'm using T-SQL and a SQL on demand against a database that was created in Spark. And I'm doing this without having to use a Spark notebook and without having to use a Spark cluster. So that's a really cool feature. A few more. This is where I can use the Apache Spark pool against a Spark table. And to show that, if I go to the workspace and I pull up the New Taxi, I can also create a new notebook and load it to data frame. And if I run this, I am now taking that data that is in a Spark table and I'm using it in the Spark notebook. So pretty straightforward. So I have the choice of either doing it this way or doing it through the T-SQL in a on-demand relational data, on-demand database on there. So what I'll see is customers who have data scientists who create this data in a notebook, but an end user who doesn't know anything about Spark wants to use it, they can go and use regular T-SQL against using the on-demand database and not have to do anything at all with Spark. And then lastly, under here, the Cosmos DB. So this Synapse link that we created as a feature recently allows you to pull data that's sitting in Cosmos DB into Synapse. The way that works is I would go through that linked, as I showed you before, and go back to the develop. I have this linked feature, or I'm sorry, the manage is where I have this feature to go link services, and I can link to the Cosmos DB as you see it underneath here. I previously linked to that. Once I do that, when I go to data and I click on linked, you'll see I have this Cosmos DB. And what I can do with that is I can right click it and I can go and say I want to put this in a notebook, and it creates the code to go and pull that into a Spark notebook. And right here, this was added today also. I can now do select top 100, and I can query that data using on-demand T-SQL. And I just got to fill in the key that I would get from the Cosmos DB portal and fill that in there. And now I'm using an open row set. I can query data in Cosmos DB using regular T-SQL, which has never been possible before. A couple of the comments before I pause for questions is I get this asked a lot now with customers is, do you support Delta Lake in a common data model? And yes, if data is sitting in Data Lake Store Gen 2 in the Delta Lake format, you can interface with that. Now there's some caveats to that, and I list that here, and I'll make this deck available. So Delta Lake is supported in limited quantities right now, and the same with the common data model that is also supported. If I land data in the data lake in the common data model format, can I query that? And yes. So some caveats to that in my blog, I go in more detail about what those caveats are. So let me pause there for questions. Yeah.
Hi, James. I do have a question here, and that is
Okay.
about, you said Delta Lake, and that is which I believe is a feature also supported on the Azure Databricks.
Yes.
And I saw that I think it was like SQL pools is out, and Spark tables. They are features that we'll be able to. I think it's on the preview right now how to access them as well.
Yes.
Now, what do you see in terms of performance? Spark tables, SQL on demand, or how should they be best used? Are you going to cover that, or you can talk a little bit about it?
I'll talk a little bit now. When you get to performance, which is a very tricky topic, because the performance depends on a lot of things. Which computer you're using. Is it on demand? Is it provisioned? Is it the Spark? Where are you getting the data from? Is it data lake? Is it a relational database? And if it's, say, you're getting it from a data lake, well, what format is it in? Parquet, CSV, JSON. How large are the files that are sitting in there? Are you putting them in certain folders? And so there's not one folder with a lot of data in there, a lot of files in there. Lots of different things to think about on there. Microsoft is starting to come out with some performance metrics that talk about all those. And now adding more complexity is I can take that data in the data lake and I can put a Delta Lake on top of that to get additional performance over it. What does that mean? How much faster does that make it? Does it depend on the data types? Yeah, it does. So it could be a very long discussion. And what I wind up telling customers is, here's all the ways you can query the data. Go and do it. Do a POC. See how fast the data is, how the queries are for your particular use case of the data, and see which one works best. Because maybe you don't have people who know Spark, and you can avoid Spark, and you can avoid the extra complexity of Delta Lake if you get what you need out of using SQL on demand against data sitting in the data lake, or move it to a relational database. So lots of ways to say it depends on that question. So it's great we have all these additional features, but it does add a lot of complexity when it comes to finding out what is the best for your particular use case.
All right. Folks, feel free to enter your question in the live chat. And to do that, just make sure you're subscribed so you can have access to it. And I don't see any questions right now.
Yeah, and so going back to this was the results of when I executed Spark. You'll see it tells you how much it used core-wise, and then it returned the results here. You can go to monitoring to see more of what that entails behind the scenes. But once you run this the first time and it starts up that Spark engine that was sitting there shut down, all the queries will run in a few seconds after that. Now, I wanted to show the power of MPP. If I go to data and I look at SQL scripts or develop and I look at SQL scripts, I have one here called Query with Synapse. And this query that I'm going to run right here is pulling together 5 different tables, joining them. And this sales table has nearly 30 billion rows in it. And you can see that query ran in just 4 seconds on there. There was no tricks up my sleeve. I didn't cache any of this. This was the first time I ran it since I fired up the cluster. So if I run it again, part of it may have been cached. So instead of taking 4 seconds, it now takes 2 seconds on here. So amazing. You run something like this in S&P, regular SQL Server, and it could take minutes, even hours on there. So this is why customers are using the MPP technology when they are using truly big data and have so much data that takes way too long in regular SQL Server. Another thing we added is this copy statement. So for those of you who are familiar with pulling in data previously within external tables in SQL Data Warehouse, we added this copy statement right here. And in this copy statement, all I need to do is specify where this file is that I want to import. And I put in what format in there, and then I have security on that. And it's going to take this file and import it, in this case, into a Twitter table that I've created here. And it's going to do this very fast. Think of this as faster than Polybase and easier to use because of just one single statement that it has in there. So copy statement will be a big part of importing data in the future for customers. You can still use Azure Data Factory, which will use this copy statement if you specify that. Under some of the features, you can say, I want to use the copy statement and such. So a great new feature that's getting a lot of excitement from customers. The Spark notebooks, to show you what you can do with that, if I go to the pipeline here, oops, the wrong one, the market data migration here, you'll see in here, I have this notebook. And as a task within this pipeline is I can go and under settings, you can see I can call this notebook. So Data Factory could be that orchestration tool that runs notebooks. And if I pop open this Apache Spark, which is this new interface, and if I go through here, you'll see I previously ran this, and this is the output of all this. So in this case, I'm running against a CSV file, and I'm updating the data that's being pulled in, and then I'm writing it back out to the data lake. Something more sophisticated is if I go back into my notebook of product recommendations, this shows you where I can import a bunch of different libraries, pull in data into a data frame. I can train a machine learning model at this point and output the results of that model when I run it against data. And you can see in this case, I'm trying to recommend, see how similar the products are and recommend them. Amazon's great at this. You bought this, maybe you would be interested in something else. And then I can write that result out into a table if I wish. So a lot of flexibility with these Spark notebooks. A couple of things I'll show if we go to the Power BI. This is integrated too. So if I go back out to develop and I go to Power BI, you'll see I have these Power BI data sets that I created from a workbook space that I connected to under the manage. And inside of here, I can click on this and I could see this Power BI report that I created previously. And I can interface with this. I can build it out. This is using a decomposition tree on here. So now think of this as I can come in here as a developer. I can pull in data from a source, land it into the data lake, clean that data using Data Factory, put it into a relational database if I need the features of that, and then go and create a Power BI report on that. And if all looks good, all this can be deployed out to the end user, and they can start using these reports to create their own reports on that. These Power BI data sets, I can come in here and click a new Power BI data set. And from here, I can say I want to pull a data source in that is, and I want to use this data source that's SQL on demand, and it has this pbids file. If I click download here, so this is another way to build the reports, is if I click on this open file, it's going to use that connection information that I just specified I want to use that is in the on-demand. And when I come here, it's going to pop up all the views that are underneath that on-demand. And I can just pick one like the Twitter view, and I can load it in there, and it's going to pull that data in, and I can start building a report out of that on there. So they made it really easy to interface with Power BI outside of the environment by passing in that connection information. And then you'll see here, I think I filtered it to just show one. Yeah, so that's that. You can continue using SMS on here. As I mentioned before, I just put in the connection information. So here I have these registered servers. And if I look at the properties of that, that's what I showed you before, that SQL endpoint. I put it in there, and then I can continue using SMS if I want outside of the Synapse Studio. And then I can just come here and I click it and do all those nice, cool things that you get out of the SSMS. There's monitoring capabilities inside of here that are being built out. For now, you can do things like look at the SQL requests that were being run. Right now, it doesn't support on demand. That's coming in a few days. But for the SQL pool, I can go in here and I can see what was run. I can click on that and I can get some details of that. So if I'm a DBA and I want to see what people are running and maybe improve things, I can look at it this way, or go through SSMS. I also have the Apache Spark applications on here. I can come in here and see what people have ran and click on that and get some specifics for those Spark details on that. Another cool thing that a lot of people are not aware of is if I go and I want to do a quick start on here, shortcut the process of building out solutions. If I go to data and I click on this plus, you'll see these samples. Underneath here, I have samples for data sets, so I can quickly and easily pull in a data set maybe of COVID, and I can use that to build out reports in there, whether I'm just playing and getting to know this, or maybe I really want to use this data because it's real data for a solution. I go to notebooks and a bunch of sample Synapse open source Spark notebooks that I can use. And you'll see things in here like, well, if I wanted to pull in, use the data lake, here's an example that they have in here of a data lake on there. So look through these, you can see a lot of ways to shortcut your process. There's the same with SQL scripts. Underneath here, there's a bunch of SQL scripts that will show me, for example, how to export data to a CSV file using CTAS, which is an option called create external table as select. And then finally, pipelines. These are like the templates you would see in Azure Data Factory. So I can come in here and again, the quick start things. And if I want to say copy data from a SQL on-premise to SQL Azure on here to Synapse pool, I can pop this open and use that as a sample going forward on there. And then finally, a federated query. This is really cool that I created this to show the power of a federated query. If I go to SQL to SQL scripts on here and I pull up this federated query, what I have is a select statement that is querying data sitting in Data Lake Store Gen 2. And I created a view on this. Then I also selected data from, pull up here, from a Spark table, and I created a view on this. And then finally, I created a select statement on Cosmos DB and created a view on this. And what I did then is take all three of those views and created one select statement from it. So in this query, I'm taking data sitting in Data Lake Store Gen 2, a Spark table, and Cosmos DB, joining them all together to get my results here. And just in 6 seconds, I am getting the results back of that. I didn't have to move data into one single source. And also, when I run a query on any of these technologies, it actually pushes down the query. So in this case, if I look at the one on the Cosmos DB, it is taking this query, going to Cosmos DB, running that query on Cosmos DB, and returning back just the results. So a true federated query where I can pull in data and pull it in as it sits. And I can also push down the query processing on the compute power of all those various storage mechanisms and then return back just the results. So then I can create this as a view called VQ combined. And whenever I run this, either through this portal, Synapse Studio, or through, say, Power BI, behind the scenes, it's going through and within a few seconds, pulling data from all these various sources. So it's a really cool solution. This will be expanded to have other sources in the future. But even right now, this is a tremendous benefit. If the trade-off is it won't be as fast as if you pulled everything in, but you're saving a lot of ETL writing, code writing for this, and you're also doing this very cheaply because you're just paying for when this query is run. So I'll pause there for questions.
All right, folks.
We good?
Feel free to enter any questions here you may have. So far, I know it's a lot of great information being shared. So don't hesitate.
Hopefully we're still connected.
Oh yeah, we are. Yes, and there's a lot of great information there being shared.
So I'm hoping all's good. I will continue on for a few more minutes. There's a couple of features I want to talk about that are inside of Synapse that a lot of customers are using. One of them is this materialized view. And this allows me to create a view that aggregates data together and puts it into, think of it as a summarized table. And I can then run queries against this aggregated view, but I don't have to specify the aggregated view. If I aggregated, say, 5 tables together, and I ran a query against one of those 5 tables, the query plan will know, oh, wait a minute, that results are already in the materialized view, and I'm just going to pull from that materialized view. So tremendous performance increases can happen if you create materialized view. And the cool thing is if it's source data from that materialized view, say one of those 5 tables gets updated, instantaneously it'll update the aggregation of the materialized view. So it's never out of date. It's a synchronous change that happens. The other is the result set caching. So this is where it'll take queries and store the results of that query in a cache. And if it sees a query that's the same as the previous one, it'll just use what's in the cache. So queries that could take minutes, seconds, can be returned in milliseconds if it's the same query on there. And then finally, I wanted to mention the workload management. So this allows you to specify the resources that a end user or a group of users can use so they're not overwhelming the system and taking all the resources. You can classify this a few ways. One of them is by isolation. So think of it as I create this workload group that's going to be used, for example, just for loading data. And I can specify the min and max percentage that that workload group is going to use. I also have the ability to have workload importance. So it used to be that if I submitted a query, it's waiting in a queue for everybody, all the other queries to finish. If somebody submits a query that has higher importance, it'll sort of cut in front and run that query. So that's another way to isolate queries and have them run earlier than what other queries would run if they have less, if those other queries have less importance. And then there's a workload classification. The idea being I can define workload types and classify them. For example, any login that's ETL related. And so if I define that classifier, the way it all fits together is I can have a data load that's a workload group called data load. Oops. Sorry about that. So I have this work group called data load that's isolating out queries that are only going to use, that can use 20 to 100% of the CPU. I then have a classifier that is anybody who has an ETL login will fall into this data loads group. So it'll get between the 10 and 20. And I'm also giving them high importance. So you'll design a system to segregate the resources and give what should be have higher resources, and have less resources. So this is a great way to not have somebody overwhelm the system and to do things like anybody who wants doing data loading should get a higher amount of CPU and a higher priority than somebody doing, say, dashboard queries. All right, and the last thing I wanted to mention is how now with all these features, combining Synapse and Power BI and all the features in Power BI, like in-memory tables, composite and direct query, those can be used in combination with Synapse to have a tremendously fast performance to the point where you can even have dashboards that are going against Synapse if they're using the results of cache and such like that. So a blog that I have that goes further into detail on this too. It's on my site, but it allows people to do a lot of things they never imagined with Synapse. So I'll pause there for questions. Hopefully you're back.
All right, let me check. Yeah, there is a question here. Which which Microsoft certification exam cover these topics?
None. There are no exams specific to Synapse yet. So we have individual ones that cover Power BI. There are ones that will touch on the SQL Data Warehouse, the GA version that has the SQL pools in the public preview version, but because this product is not yet GA'd, there is no certification for it. But you can expect, I would probably say sometime early next year, that there'll be certifications for it, specifically for it.
All right. Any other questions out there, folks? Remember, just subscribe, go to the chat, drop a question there. And remember to like and comment. Anything else there to add, James?
That's it. I'll share this deck. There's a number of other slides in here, and the deck can be used as a great reference to learn about the product in more detail. And the best thing you can do is just go and start playing with it. I realize that's a challenge if your company doesn't have a subscription, but be aware there are labs coming out and workshops coming out that allow you to play with this product without having to have a large cost. But also keep in mind, if you want to play with this product and not use the SQL pool part of it, it's going to be extremely cheap. You're just paying per query. So it could be pennies per day to play around with it. You'll get into the costlies if you fire up a provision pool and those DWUs are set kind of, if you set them too high, then you can run up a lot of costs. But right now it's in public preview. You can go to the portal, you can start playing with it and get familiar with it, because this is going to be, or really already is, very big for customers that I'm seeing. And I think it's just going to get a lot more popularity.
All right.
Ah, you want a close up?
Yeah.
I don't know if that's a good idea, but I have a very high def camera.
All right. All right, James. Very exciting. A lot of great information here about Azure Synapse Analytics along with Data Lakehouse. I hope that everybody really enjoyed. We still have a couple minutes, so please drop your last questions here that you may want to. And I also like to take the opportunity here to thank James once again for making the time to present at the Microsoft Data and AI South Florida user group. We really appreciate that, as well as to everyone watching right now our stream. Thank you very much for following, subscribing, supporting the group, and most important, it's a great opportunity for you to learn from a very experienced professional who is also a Microsoft employee and deals with this day in, day out.
Yeah,
And
and feel free to email me if you have any follow-up questions.
and you have his email there. What I'm gonna do is put a link below in the description as well, where you can find the deck that he's gonna share with us. And what I'm gonna do too is, if you are registered at the user group via Meetup, you will send an email telling you how to get that deck. So if you're getting started, as James pointed out, you can probably go there, use your subscription. He mentioned that by not using the pools, you will be able to perform quite some tasks there, and cover a lot of the materials he talked about. Sounds about right?
Yep.
All right, folks. Let me take a look here, see if we have any questions. Not at this time. So, anything else you want to add here, James?
Yeah, I'll just close it out since we had a couple extra minutes. The one question I get a lot from customers is the benefit of this is essentially a PaaS solution on there. We're going to perform, Microsoft's going to perform upgrades and patches to the VMs behind the scenes, to the product itself, and customers are concerned, well, are you going to patch and have interruptions while I'm having end users access the database? And while we can't guarantee that there won't be any interruptions, we do allow you through a maintenance schedule window to specify when you will allow us to have a maintenance window. And you can choke out a block of time, so you can say, hey, go ahead, Microsoft, make the patch and do it on Wednesdays from 1 to 2 a.m. And I've never seen more than a few minutes outage, but customers didn't want to have that outage happen in the middle of the day. So this maintenance schedule that was added is very beneficial. And then the other thing is backups. There are backups automatically taking, usually every 4 hours. And if something were to happen to, say, the region you put your database in, it could be in, say, US East. The backup happens, and it has a copy in US East, but it also copies that to another region, say US West. So then you can go into the Azure portal and you can say, and you can log into and say, I want to create a database in any other region. And you can say, I want the database that was backed up from the East region. And it will say, oh yeah, we actually backed it up to the US West region. And then you can say, I want to restore that database and pull it into the portal into that different region. So this allows for disaster recovery. And the backups usually restore in under 20 minutes, no matter what their size is, through the snapshotting. So we see a lot of customers love that because they're confident that if anything happens, which is extremely rare to happen to a region, they can always go and restore it and to another region and keep on going.
All right. Yes, definitely. In terms of uh, keep the operations alive and going here with minimum to no impact.
Yep.
And principally if they are able to set up the, as you said, the regions here on how to best design their architecture there to keep it
Yeah.
all. We do have a question here from Gaspar. He's asking, Databricks introduced the Photon engine for Delta Lake. Is this something coming to Synapse as well?
I caught you cut out there. Databricks, what was that?
Sorry. Databricks introduced the Photon,
Oh,
Photon.
Photon.
Yeah.
Okay, yeah.
Is
So
this
that's a
something that?
technology.
Sorry. Go ahead.
Yeah, so that's Photon's a technology to speed up Spark, we'll say it that way. And that feature is coming to the open source Spark that is within Synapse. So you can expect that soon under the public preview. And then also I should mention that if you're using Databricks, you can continue using Databricks outside of this. Eventually Databricks will be more integrated with what they tell me into it. But we see a lot of customers who could use Synapse and land data in a data lake and move it into a relation database and do all these things with it. And then outside of that, they can fire up Databricks and attach to that data lake was built within Synapse and pull it into Databricks. So it's not as you have to use one over the other. You can continue using Databricks along with Synapse.
I see. Uh, any other questions there? Because I also saw, I think there's some integration for Synapse to link to Amazon S3 as well as I forgot the other piece, but some products, some services available at Amazon as well. You use that as a source.
Yes. So you can go into the data factory part where you're doing that copy data wizard, and your source could be Amazon, and you can pull it out of there and land it into data lake in Azure. So we have a lot of customers doing that. I think eventually the federated query will have Amazon as a source too, so you can have that federated query that's using that. But for now, it's available, but only to pull data from Amazon into the data lake or into Synapse relational database.
Awesome. That's a lot of great features. Let me see if there's any more questions. No, that's it there. All right, folks. We are all good. I think so. Hey, I'd like to take opportunity here once again to thank James Serra for making the time and presenting here at the Microsoft Data and AI South Florida, as well as to those attending today. Really appreciate it. The video will be made available soon, so you can go do a recap and review the great information he has shared. And the deck will be available here pretty soon, soon after we have received it. And if you folks have any questions, I know that James has shared his email, or if you want to use the user group message, I'll share with you his information there, how you can reach him, and or the question that you may pass through, and we will relay. No more questions. All right, folks. Really appreciate. I would like to thank everybody for making the time there, and have a good night. And remember, stay tuned with us. Don't forget to click to like the video, drop a comment, and subscribe. With that, I bid you all farewell. Have a wonderful week there, and stay tuned. We will have some more presentations coming up. And thank you. Take care. Thank you, James. See you there.
Yep.
Bye bye. right.